Hexavalent chromium is a soluble and potentially toxic form of chromium commonly detected in drinking water at low concentrations. It can enter groundwater from natural sources or from industrial runoff and can be a contaminant in soil from industrial emissions. The EPA regulates the amount of chromium in water, and the reference dose, or safe dose for oral exposure, is 0.003 of a milligram per kilogram of body weight per day. But this value was developed in the 1980s and is based on a bioassay conducted in rats more than half a century ago. The EPA lists the confidence in this value as low. By incorporating newer studies about chromium's mode of action and by applying pharmacokinetic modeling, toxicologists and risk assessment professionals now have much more certainty about this number. The researchers used data from a recent 2-year study of hexavalent chromium exposure by the National Toxicology Program, which found that it caused oral cavity tumors in rats and increased the tumor load in the small intestines of mice, along with other effects on the pancreas and liver. The team investigated how hexavalent chromium causes cancer and concluded that the intestinal tumors were the result of repeated wounding and healing. This mode of action does not involve direct chemical-mediated DNA mutation in gut stem cells and only acts at very high concentrations, such as those used in the mouse study. To understand how much chromium it takes to create health effects, the group first modeled the pharmacokinetics, or how chromium moves through the body, in rodents, including the amount moving out of the stomach and into the small intestine, through the small intestine, and out into the blood. Then, the toxicologists use benchmark dose modeling to quantify the relationship between the dose in a given tissue and the biological response or adverse outcome. Finally, the team converted internal doses in the rodents to doses for both normal and susceptible people using a human pharmacokinetic model. From this, they derived a reference dose of 0.003 of a milligram per kilogram of body weight per day, which protects against both cancer and non-cancer effects. Although the reference dose is unchanged from the value calculated by the EPA in the 1980s using the older study, the team believes that the confidence in the dose is high because of new data and a reduction in various sources of uncertainty. As such, there is now substantially more scientific confidence in the reference dose that has been used to set drinking water standards and soil cleanup guidelines for the past several decades.